Hello, reInvent. Hope you all are doing wonderful. Welcome to API 202, using an event driven application pattern to improve customer experience. My name is Ish Singh. I'm a senior solutions architect with AWS and I work with Amazon. In this session, you will learn how to use location capabilities such as tracking, geofencing, routing, map visualization, and geocoding in your serverless applications in a way that is secure, protects the privacy of your users, it's scalable, and improves your customer experience. Using Amazon Fresh, Amazon's grocery pickup service as an example application, we will estimate customer arrival time to direct staff and customers using Amazon Event Bridge, AWS Lambda, Amazon Location, and AWS Amplify. Today's agenda will include introduction to event-driven architecture, introduction to Amazon Event Bridge, introduction to Amazon Location Service, and followed by an architecture deep dive for curbside pickup scenario. And we'll cover implementation best practices and lessons learned. Innovation requires change, and the easiest kind of change to drive is lots of incremental innovation and lots of experiments. You can learn faster by making lots of little changes rather than waiting to take one big leap. That's where decoupled event-driven architecture with microservices is very valuable. You can iterate on each microservice, add, remove event, producers, and consumers to deliver whatever pace of innovation you choose. Let's take a deeper look at event-driven architecture and how you can use AWS Event Bridge to build and scale event-driven applications and workloads. A typical architecture might be set up to operate in a traditional request-response fashion. A client sends a request to place an order, the order service does its processing, perhaps calls a payment provider, and then also calls the delivery service. And in that entire time, the client is waiting for a response. When the order service completes all the steps, it returns the response back to the client. This process is stateful and synchronous. A typical implementation of a synchronous architecture on AWS might look like this, where you have the customers from mobile, web, and third-party services connect to your workload via Amazon CloudFront on the edge, and then leverage API Gateway to route those requests to web services running on Lambda, EC2, Fargate, etc. Other services might directly be connecting to the regional API Gateway endpoint. Your application code would then further use a data store such as DynamoDB, RDS, etc., or call other services in your or peered VPC. Your service might have dependency on external or third-party systems. Let's look at a slightly different paradigm and the paradigm of events. So what exactly is an event? In the simplest terms, an event is a signal that a system state has changed. Events in system make it much easier to build applications that can be horizontally scaled. Event-driven systems are loosely coupled and typically consist of event emitters or producers, event consumers, and event channels. And because events are observable in nature, they open up possibilities that are not option in monolithic and synchronous architecture. Events are observable, not directed. In a command model, each command is explicitly issued to a specific recipient. Events, on the other hand, are merely observable by other systems. And the benefits are that event producers don't need to have any knowledge about who's listening to those events. This keeps them simple, allows other services to consume events without needing upstream changes. Building an event-driven application in AWS is fairly easy, and it's simple. And you start with a Lambda function. You can write Lambda function in multiple languages, Node.js, Python, C#, Java as an example, and others. You use Lambda function, and that Lambda function gets invoked based on certain events that get triggered. And those event sources might be a database change, a request to an endpoint, or a change in resource state. Lambda function then further calls other AWS services or change in data source such as DynamoDB, RDS, or make calls to other service endpoint somewhere on the internet. So what makes an event-driven architecture better? Event-driven architecture has several benefits. Event producers and consumers don't need to be aware of each other. A producer detects a change in the system state and represents that state in a message. A typical event message will then have a header and a body that reflects the change in the system. The event message are routed to an event channel or multiple channels. Specific selection criteria and filters are then applied to those events based on the content of the event message. These filters can be used to assert different conditions and create notifications. This loosely coupled event-driven architecture makes it very easy to implement, maintain, and secure the applications. And there are other benefits as well, namely ability to horizontally scale, reduce operational cost and complexity, better fault isolation for more resilient architecture, programming language and technology agnostic, and you get greater agility and flexibility. Amazon EventBridge is a serverless event bus service from AWS that offers you all the benefits of event-driven architecture. And you only pay for the events that you process. Scaling is simplified and helps you avoid increase in costs to sustain and maintain resources. There are no upfront costs and no specialist knowledge is needed. Amazon EventBridge offers customers ability to handle several use cases. We'll discuss 3 common use cases. Take action. When an AWS service triggers an event, you can use EventBridge to execute a Lambda function, which can further make changes to your applications and resources. You can run workflows. Based on a certain application event, EventBridge can start a workflow using step functions. Or you can apply intelligence. When an event is triggered from, say, an integrated SaaS application, EventBridge can send that event message to Lambda, which can further use machine learning and AI services to apply intelligence to that message. So let's take a look at how EventBridge works. It all starts with an event source. These can be any one of those hundreds of integrated AWS services. Event sources also include any custom application you write or an external SaaS application you use. When you use a SaaS application integration, there's a special resource called a partner event source that provides a logical connection between the partner's system and your AWS account without the need for provisioning and managing cross-account IAM roles or credentials. At the core of EventBridge are event buses. If you're familiar with the CloudWatch events, default event bus, this is exactly the same thing, except you can create your own custom event buses as well as event buses dedicated to ingesting partner events. Once you have an event bus, you can associate different rules with it. Rules allow you to match against values in metadata and payloads of the events ingested and determine which events should get routed to which destinations. And finally, you can associate multiple targets with each rule in order to send the events that match to the appropriate destination. Targets allow you to do things like invoke a Lambda function, put a record in Kinesis data stream or Firehose, start the execution of step function workflow, or start a task using ECS or Fargate and many other use cases. As the complexity of your architecture grows, you'll begin to ask yourself questions like, how do I describe and version events? How do I enable my development teams to easily discover those events in my organization? How do I increase developer productivity while maintaining consistency across implementations? This is where the schema registry comes in. It allows developers to define event structure or schema using a standard specification like OpenAPI and also use a JSON schema. This removes the need for developers to have to look through documentation and allows them to consume and validate events programmatically. EventBridge schema registry makes accessing those schemas easy by centrally storing schemas generated by all your event sources on any developer so any developer in your organization can access them. When the schema discovery feature is turned on, all events sent to an event bus are automatically added to the registry. So there's no need to manually create schemas. But of course, you have the option to do that also. And we provide you templates as a starting point. The schemas can be used to download code bindings, which allow you to represent the event as an object in your code and take advantage of IDE features such as validation and auto-completion. You can download code bindings for programming languages such as Java, Python, TypeScript, and use this code in your IDE via AWS Toolkit for IntelliJ and VS Code, or via the serverless application model CLI. Let's look at how we can capture real-time location-based events in our applications and improve customer experience. Location is an essential component in today's applications, enabling capabilities from asset tracking to location-based marketing. However, developers face significant barriers when integrating location data into their applications, including cost, privacy, and security compromises, along with tedious and slow integration work. Also, customers may not pursue enriching data with location functionality or creating certain location-based applications because the cost of location data is too high to produce a positive return on investment. We'll see customers integrate location-based services into 4 main use cases. Tracking assets and resources. Companies can reduce losing valuable assets when they know where they are. Also, understanding where your assets are provides visibility to optimize asset use. For example, one of our postal customers optimizes the delivery of carrier bins to their customers to ensure they always have enough bins for the materials they want to go into that post. Routing and delivery. Companies that provide delivery services can more efficiently route their trucks to delivery drivers and find the shortest route using the routing in their application. Also, can pair locations service with geofence, alert a location preparing goods that their driver is nearby when the driver enters a geofence. They can also prepare the goods for timely pickup so the drivers doesn't have to wait. Visualization. Show your customers where your locations are on a map and how close or far away they are from your locations. And customer engagement, also referred to as geo-marketing by many. You can send offers to your customers based on their location. If they are near your store, you can send a special offer if they come in and purchase that day. We know that developers are asking for a way to easily include location functionality in their applications. So what they don't want to do is give up control of their proprietary data and user privacy, or paying excess prices, or spending months to build and operationalize integrations with one or more location-based service providers for different use cases and geographies. Location-based service also has challenges. And these challenges are getting to production faster. Building integrations with third-party location-based services takes time. It's not just building, but operationalizing and integrating with the rest of the AWS-based app, metric, logging, auditing, event-driven programming models. None of that comes out of the box with bespoke integrations. Onboarding new providers. Customers have told us that they want a native location-based service, or referred to as LBS, offering on AWS. Building an integration to a third party is just not as easy as opening up a new AWS console and building in a familiar environment. Onboarding a new provider is pain, and if it's anything like how we do it in Amazon, you need to set up new billing relationship, set up a new account, manage security credentials, gain AppSec approval. Totally doable, but it's not a value-added work. Getting great data. Customers have told us that they need location data that is comprehensive, accurate, and fresh. And attaching yourself to one location-based provider can be okay if you're experimenting in one smaller area. But those with national or global footprints have quickly discovered that LBS provider coverage is inconsistent. And what worked well in Berlin may not work well in Boston or Brisbane. Now, you may like one provider point of interest search, but someone else maps. So getting the best data for your application without making compromises or building multiple integrations is tricky. Managing security and privacy. Customers are very concerned about guarding their location data, their personnel, their fleets, their assets, and their facilities. Your end customer's location data is also subject to stringent privacy regulations. Most enterprises and governmental organizations cannot bear to cede any rights to their location data, have it commercialized by a third party, or even leave the administrative control. Controlling costs. Traditional location-based services have been rather expensive, unless you're willing to make privacy concessions. Customers have told us that there are many applications that would benefit from including location data, but they don't have a positive return on investment with the prices that prevail today. One customer told me they ran up thousands of dollars in costs just for experimenting with a location-based provider, and costs are constraining innovation. That's why we built Amazon Location Service, to bring you these benefits when you need a location-based service. Easy access to high-quality data from two trusted global experts, ESRI and HERE. You can access that data through consistent Amazon Location API and console. Cost effective. We set out to price the service so that you could innovate without being constrained by prohibitive costs, with a generous free tier to get you started. Depending upon your use case, Amazon Location Service can be 2 to 10 times less costly than leading providers. Privacy and security are built into Amazon Location, improving your enterprise security and your end users' privacy. Shorter time to production. CloudWatch metrics, logs, alarms, CloudTrail API logs, and EventBridge integration are built in. You can build and operationalize your application much faster than you would with a custom integration. Amazon Location Service features include maps, visualize surroundings and overlay data, places, convert addresses to coordinates, and vice versa. So forward and reverse geocoding. And you can also do points of interest search, tracking where your assets, fleets, your resources, and where they are at any given moment. Geofencing, you can define a spatial area and you can react based on when tracked assets enter or exit those geospatial fences. We drop an event in Amazon EventBridge for you to react to. Routing, planning routes based on different points, multimodal travel, etc. And Amazon Location Service provides you SDKs for web, iOS, and Android. Amazon Location Service has multiple features to offer, and they're offered in two different ways. So you have maps, places, and routing that you choose the data provider for that, whether it's ESRI or HARE. And these are external queries, but they're anonymized. Geofences and trackers, however, that data never leaves your AWS account. So you are able to protect your data. So when Amazon Fresh wanted to build curbside pickup, they started out with three top requirements: ease of implementation, best customer experience, and operational efficiency. So let's look at why Amazon Location worked really well for Amazon Fresh curbside pickup. Amazon Location's strong data privacy and protection terms means that Amazon Fresh customer data is never exposed. Real-time routes with traffic improved the estimate of arrival time, reduced wait times, and increased store efficiency. Also, fast and easy integration allowed Amazon Fresh to experiment and improve customer experience quickly. Low costs allowed use of optimal route calculation frequency for best experience, and they were able to remain within budget. And now I'd like to welcome Steve Johnson to go over an architectural deep dive into this curbside pickup scenario. Thank you. Over to you, Steve.
My name is Steve Johnson. I'm a solution architect here at AWS, and I'm going to be going through our curbside pickup application demo. And just to give you some context on this, this is an application in two parts. There's a web application that will show a map that tracks the progress of our customers as they create orders and drive towards one of our stores in the Pittsburgh area. So here we have a basic architecture. This is not event-driven, but it does represent one way to architect our application. And as you can see, we have our web application represented as store operations, and then each customer will have a mobile device that updates the customer's position, as well as creating orders and so forth. So this demonstrates a traditional sort of invocation-based architecture, right? So every time we want to write data to the system or update data, we communicate directly with the database, right? So if the customer wants to update their position, they're going to use the AWS library database category to write directly to DynamoDB. If any part of the application wants to fetch information, they're going to do it by reading directly from the database, such as our store operations web app, which is going to use the Amplify libraries to poll the database, hoping to find new information to plot on the map. And one of the ways you know you're not doing event-driven architecture is reliance on things like polling. Now, polling is not the same as using timed events. You know, some events should be timed, and it's usually on the event generation side, right? Sometimes it is a good idea to have events that are periodically fired, you know, for various reasons. But in our case, you know, sort of the anti-pattern here is to have a map display that is continuously polling a database, whether there are updates or not, right? You're just hoping there's an update and you're going to grab it and update the screen with that information. So even though this looks like a simple application, it actually is it's a little more complicated to code. And as it turns out, when you just sort of have this read-write client-server type architecture, you end up doing a lot of business logic on the clients, right? So the clients write the information, the clients read the information. If you want to do something like test whether a customer's location is within a geofence, usually that type of work is done on the map application on the client. And if you're building web applications or mobile applications, generally the more you can do on the back end, the better. And there's a couple reasons for that, right? If you do change that logic, it's a lot easier on web and mobile applications to change logic on the server side in most cases, so you don't have to redeploy your applications, upload it to the App Store, what have you, right? So if you can do a lot of your logic on the back end, you're better off. Our next slide shows the way we actually developed our curbside pickup application using the event-driven principles that Ish talked about in the presentation. So once again, we have our store operations web application that's talking to the backend through the Amplify libraries. It's pulling map tiles from the geo category, and it's talking to AppSync using the API category. You'll also notice the mobile application is using Amplify to talk to AppSync. So let's talk about why we're using AppSync in an event-driven application. So AppSync is our managed GraphQL service. And if you're familiar with GraphQL, it can be used as an API layer in an application, the way we're using it here, similar to REST API layers in architecture. But GraphQL has a very interesting feature that is, in addition to the basic CRUD operations you can perform using REST or GraphQL, there's another feature called subscriptions. And we make heavy use of that in this application. So instead of having the web application pull the database directly, hoping to find updates to the positions or new orders to plot on the map, AppSync is going to detect when changes are made to data that clients have subscribed to. So just as an example, the store operations web database is going to tell AppSync, hey, I want to know when a new order is created or deleted for that matter. I want to know every time an order's position, or I should say a customer's position, is updated. And I will update the location of that customer on my map. And because we're using the subscription mechanism here, AWS AppSync is actually going to be generating the event that's received by the store operations web app. And just for your information, that is sent over to the client using WebSockets. So you can have a pure HTTP/WebSocket client, and it will communicate beautifully with AppSync. The other event-driven part of the architecture that saves us a lot of work is using Amazon Location Services geofencing and tracking capability. As we've heard before, if you associate a tracker with a geofence and you start updating positions of devices on that tracker, if one of those devices crosses in or out of the geofence, it will generate an event, right? And send it over to Amazon Event Bridge, which we've conveniently hooked up to a Lambda function. And that Lambda function will update the database for us. So, for example, if we have a geofence around our store or the parking lot of our store and customers arrive and cross into that geofence, we can update the DynamoDB database with a status of arrived, which we're actually going to demonstrate in a little bit. So enough boxes and lines for now. Let's go ahead and actually show you the web application. So I'm going to bring that up. Okay. And as you can see here, we have a map provided by Location Service. And this is a vector map of Pittsburgh. a shout out to Matt Klein, who did a lot of the work on this demo. So thank you, Matt. And we actually have, I believe it's a Whole Foods here in Pittsburgh. If anybody's from there, you could verify that. And what we're going to do is first demonstrate what this looks like without the event-driven architecture. Right now, we do not have our subscriptions turned on, right? If we click that button, it will subscribe to various events. But for now, we are going to demonstrate how this works if we were going to poll the database. And that polling is represented by pressing this button, the reload data, which basically just goes out to Dynamo and grabs some data. So for the purposes of the demo, our clients, our customers, and their cars are going to be simulated by a script we wrote. So we're going to go ahead and start the script, which should generate 4 orders. So we've started generating some of the data. You can see that the map is not updating at all. So we're going to pretend to poll here, or I guess we are polling here by pressing reload data. And you see all the data comes up at once, right? You'll see that these place markers for the 2 orders, and I'll just reload again, and we have our new ones here. So as I click reload data, a couple things are happening here. You'll see I'm grabbing this data and plotting it on the map. You'll see there's actually multiple markers per order, and that's just an artifact of our polling, and it actually makes it a little more complicated to plot this on the map. And you can see some of the orders have already arrived here. We have a status of arrived. So 3 of these have arrived, and when I hit complete here, it's going to clean up all of the back-end data for us. And you see I have to actually reload the data to update any part of the screen, right? So our last order has arrived, and this will spin forever until I hit reload data and it finally disappears. And you can also see we still have some artifacts here on the map. So I'm just going to restart this application, clear the map for us. I'm going to run the same simulation, but this time I'm going to click subscribe to events. So by clicking that, the application is listening for updates to the orders and the device positions from AppSync. So let's go ahead and start up the simulation again. And you'll notice I am not refreshing the page, but as data becomes available, it automatically goes to the application. So I've created the first order and now the second order. And all this is being done without any polling on the application itself. It's simply waiting on those WebSockets for the data to come across. Those events are generated by AppSync automatically, as our sort of device simulator or customer simulator is updating those positions of those little placeholders there. So you can also see, the blue order has arrived, order IA, and it figures out that it has arrived because, as I showed you before, we've created a geofence around the store. So whenever one of the devices crosses into that geofence, we know they've arrived in our parking lot. And as you can see here, all of this happened in near real time. As soon as the data was available, it's updated it automatically on our web application. And because we've subscribed not only to order creation, right, and position updates, we've subscribed to order deletion as well. So if I hit complete here, it's going to disappear from the sidebar here, right? So one of the great things about doing this, right, is it's easier to write these applications if you're responding to events and you know what the data looks like as it comes in, right? So when you make a GraphQL subscription, you tell AppSync what you want the data to look like as it comes in, and it comes in just as a JSON file, right? Or I should say JSON data over the WebSocket. And one last thing, I want to show you some of the code that was written here. And I've got two React components. The web application was a React web application. So let's take a look at the app itself. It's a standard React application. You can see here I'm importing, just the basic React UI elements. I'm importing the Amplify libraries, including everything I need to talk to AppSync, right? So the GraphQL queries, mutations, and most importantly, the subscriptions here. So let's go down and see where we're setting up our subscriptions. You can see I'm creating a subscription that handles new orders, right? Updated orders. So when the state of the order changes, like from in process to arrived, will be updated of those changes. We have an updated position subscription, which tells us when to move the markers. And lastly, a delete order subscription. So whenever I click on close or cancel, or any action that deletes an order from the database, a notification goes to the application so we can update the display. And lastly, since we have been using location quite a bit, I just want to show you what the map component looks like. This is the map code, right? So we have a map container, which is MapLibre, and we're pulling the map objects or the map tiles from the location service. And as you can see, it's not a lot of code, right? So in the course of 127 lines of code with some white space, we've created a map container that gives you a beautiful vector map with zoom and pan capabilities. Not a difficult thing to do. So that concludes our demo of the curbside pickup, and I'm going to hand it back over to Ish so he can close us out. Thanks, and take it away, Ish.
Thank you, Steve, for the architecture deep dive and demo of the curbside pickup feature. In this session, we learned how to leverage AWS Amplify Geo to quickly add location capabilities to your app and service. Use Amazon Location to add routing, geofencing, tracking, and maps to improve customer experience. And easily integrate with other AWS and third-party services and handle events using Amazon EventBridge. So that wraps up our session for today. Thank you so much for being here. Hope this session was helpful to you and look forward to seeing you next time.